DNS, why we need DNS, and then in AWS, when we talk about your DNS service, Route 53 is what we have. Um, then we looked at what your Route 53 can do. So we can use your Route 53 for domain registration. We can use it for DNS routing. We can also use it for health checks to check whether your application is available or not, or whether your application is working as expected or not. All those validations can also be done. So we looked at what is your domain registrars, why we have your domain registrars, how your domain registration works, and then we also looked at how you can register your domain. Post that, we looked at your hosted zones. So hosted zones is what we simply use for the DNS routing, right? So, like if I hit a URL, to which IP it should go, to which server it should hit, all that routing can be done using the hosted zones. Hey, Prokshit. Um, then we discussed about the routing policies that we have in Route 53. So we have the simple routing policy, we have the weighted routing policy, we have the latency based, geolocation, geo proximity, failover, multi-value answer. So these are the different types of routing policies we have. Now in today's session, we will be looking at each of these one by one. We will be looking at examples for each of these. All right. So what I'm going to do is I'm going to launch one server, or rather two servers, all right, and we will host a simple HTML application on them, all right. So let me quickly launch this, and we are going to launch two instances. So launch instance, and this will begin launching two EC2 instances for me. So one of this is going to be server one, and then we will have server two. So right, so two servers. Now on both these servers, we will be running two different HTML pages for easier understanding purpose. For now, we are only going to use one of the server. All right, so server one. So talking about your routing policy. So the first routing policy that we are going to look at is your simple routing policy. All right. So as the name suggests, simple routing policy. It's a very straightforward routing policy, and this is the default routing policy that we have. All right. So your simple routing policy lets you configure standard DNS records with no special feature. Okay, it does not have anything special about it. It's a very simple routing policy. All right. So with this, with your simple routing, you typically route traffic to a single resource. For example, to a web server for your website. So let's say you have some application running on a server. Now, if you want to map that server to your URL, we can make use of your simple routing policy. All right. So it's nothing this is something very commonly used, and this is, like I said, a default one. And most of the time, you might see people using this. So let's see an example for this. So this is the EC2 instance that we have. Let me log into this EC2 instance, and we are going to set up a simple HTML page. So I will install HTTPD, which is our Apache server in this case, and I'm going to set up a simple index.html file. So I'll go to the var www.html, and I'm going to create this index.html file. All right, and we'll add some content to this. So let's say this is example for simple routing policy using Route 53. You can have whatever you want, but like I said, it's a HTML application. So I will save this, and then we will start this. So service HTTPD start. Now, until now, what we were doing was we were using the IP address to access the application, right? So what we did was we took the IP, we hit the IP, and we were able to see this. But in real world, this is not how we do it. All right, you will always have a URL associated with this. So your end users will access that URL, will hit that URL, which will return this response to you. Now, how do we do that? That's where we can make use of your Route 53. So the hosted zones that we created yesterday, in that hosted zone, we are going to create one routing policy. All right. So here we'll go to the hosted zone, and so in this case, we have your IP address, right? So What do you think will be the record type for me? So here I'll click on create record. Now, what type of record I'll have to use here if I'm using IP address?
You can use A or A type.
Yeah, so it's going to be an A record for us. All right. So by default, that is what it will point to. And here you have the option of giving a subdomain. By default, this will be the domain. If you want to give a subdomain, like let's say simple. So this will be something like simple dot cloudtechies dot cloud. All right. So you can give that. And here you can give the value, the IP address, and then comes your TTL. Now TTL, it stands for time to live. All right. So this is nothing but your cache feature. How do you want the cache to be stored? Now the lower the TTL, the the faster your new changes will reflect. All right. So we are keeping it to the minimum, which is 60 seconds, and then your routing policy. So we are going with the simple routing policy. So like I said, this does not have anything special about it. We're just mapping this URL with this IP address. That's all. And then click on create records, and this will create a record for us. So here you can see there's my record created. Now, all we have to do is we have to take this and hit. So now instead of using the IP address, we are using the URL. So even if you try hitting this, you will be able to see the same page. Right? So this is basically where we can make use of your Route 53. Does that make sense?
Yeah, Ravi.
So that's your simple routing policy. So like I said, it does not have anything special about it. It is simple one-to-one mapping, right? So we map a URL to the IP address, and that's all. The next type we have is your weighted routing policy. Now, using the weighted routing policy, we can define the amount of traffic that you want to be routed to your application. Now, in case of your simple routing policy, 100% of your traffic is routed to this server, right? Now, if you want to divide, like let's say you want to send the 50 percentage of the traffic to this server and then 50 percentage of the traffic to this server, then we can go with your weighted routing policy. So weighted routing policy lets you associate multiple resources. So with your simple routing policy, we have only one resource. With your weighted routing policy, you can have multiple resources with the same name, all right, or subdomain name, and choose how much traffic is routed to each resource. Now, this can be useful for a variety of purposes, including load balancing and testing new versions of software. So something like, let's say you have developed a newer version of the application. All right, now you want to test it to see whether it is working as expected or not. So what you can do is you can have two environments, your existing production environment and then your new production environment. Now, the existing production environment will have your older version of the application. The new production environment will have the newer version of the application. And you can define a weightage. Like, let's say 90% of the traffic should go to this existing production environment, and then the 10% of the traffic should go to this new production environment. And so only a few people will be able to access this. Now, depending on the response, if everything is good, you can start increasing this. So you can make this 20, 30, 40, 50, and then finally 100% so that everyone will start using that newer version of the application. That's where we can make use of your weighted routing policy. So now let me log into this server as well, and let me set up one more simple HTML page on this. So this is the second server we have. And so again, yum install httpd. This should install the Apache server for me. And then we'll go to var www.html, and we are going to create our index.html file. And let's say this is sample for weighted routing policy using Route 53, right? And we will start the service. So service httpd Start. Now what we will do is we will create our records. So I'll delete this because we no longer need that. So I can delete, sorry, can where is that? Delete this record. And now we are going to create the record for our weighted routing policy. So this will again be your A record, right? So let's call this as weight, right? And then your server. So let's say this will be server one. So we'll take the server one IP address. We'll give it over here. This will be 60 seconds. And we are going with the weighted routing policy. And here you can define your weightage. All right. So this number, it can be anywhere between 0 to 255, 255 being your 100 percentage, right? So let's say I'll set this to 50. You also have the option of setting up a health check. We will talk about this later on. And you can give a name to this. So let's say we'll call this as server one. Okay, so this will be one record. We are going to add one more record for the second server. Now the name would remain the same for this. Okay, so this is also going to be wait. And this time we are going to point to the second server. So we'll take the second server, we'll give it over here, and again 60 seconds, and this is going to be our weighted, and the remaining 50 percentage we are sending it to this server. And let's call this as server 2 and create the records. So this is how you can define your weighted routing policy. So you can see the URL remains the same, but we are telling that send 50% of the traffic to this server and the remaining 50% of the traffic to this server. Like this, you can make use of your weighted routing policy. So now if I hit this, some of your traffic will go to server 1 and then some of your traffic will go to server 2. So in my case it is going to server 2, right? So if I refresh this, can any one of you see this response, simple routing policy?
1 second. Let's see.
Mhm. Yep. Bharat?
Sorry, it's showing error.
Can you
No, I can see. There's an example for simple routing policy for using Route 53.
okay, what is the response that you see?
Wait. I mean, in the URL it says wait loud. This one, and then in the this one, like it says this is an example for simple routing policy.
Okay. So if you see here, in my case, it is giving if my traffic is going to the second server, and
Okay.
in your case, the traffic is going to the first server.
Okay.
Okay. Now we both are using the same URL. All right. But because of the weighted routing policy that we have defined, some of the traffic is going to server one, and then some of the traffic is going to server two. Okay, so this is simply your weighted routing policy. Does that make sense?
Yeah.
Yes, sir.
All right. Now, the next routing policy that we are going to look at is your latency. Now, latency would be, again, here you will be having multiple servers, but based on the user's location, all right, the server which is closest or the server which takes lesser time to respond, the traffic will go to that. For example, now let's say I'm in Bangalore and I want to travel to, let's say, Majestic. Now there are different routes that I can take, right? So let's say I'm in Kerpuram, I can go via also Remju Road and then I can go to Majestic, or I can also go to Marathali, HAL, Domlur, and then I can go to Majestic. I can also go to Kormangla. From there, I can go to Majestic. But depending on which is the fastest route for me, I will take that and go to my destination. Right? The same applies here in your latency. So latency would be the time taken to respond back. All right. So whichever server responds the fastest, the traffic will go to that server. So if your application is hosted in multiple AWS regions, you can improve the performance for your users by serving the request from the AWS region that provides the lowest latency. So to use latency based routing, you can create latency records for your resources in multiple regions. So under this, generally what happens is you will be deploying your applications in multiple regions. All right. And once it is deployed to multiple regions, you will be creating the latency record. So with Route 53, when Route 53 receives the DNS queries for your domain or subdomain, it determines which AWS regions you have created the latency records for, determines which region gives the user the lowest latency, and then selects the latency record for that region. So AWS takes care of it. You don't have to worry about it. All right. So what we do is we define this, and when as a user, when we hit that URL, AWS will validate that. It will evaluate, all right, in which region we have created that latency records, determines in which region the user is in. Like let's say as a user in the case me, all right, in which region I am in, and then selects the latency record for that region. All right. So Route 53 responds with the value from the selected record, such as the IP address for a web server. Okay. So here, for example, if you see, I have same application, but in two different regions. So this is in North Virginia and this is in Mumbai. And my user is in Singapore. So let's say I hit this URL. Now, depending on which region is closest to this user or which server gives the fastest response, my traffic will be routed to that server. This is your latency based routing policy. So to show you an example for this, again, under this, you will be having multiple records. So let me delete this and we'll create new records. So again, we'll go to create record, and this will be an example for latency. So we'll give your first server, let's say server 1, and this will be 60 seconds, and this is going to be your latency. All right. Now, in which region, for which region do you want to map this to? So let's say I want to map this to North Virginia. Okay. And then you can give a name to this. So let's call this as server 1, and we'll create one more record. Again, the name will remain the same, but this time it will point to server 2. So this will be server 2. And again, this is going to be your latency. And then the region. So let's say we will point this to Mumbai. Okay, so let's say this is server 2. And we will create this record. So now we have created our latency records. And you can see if the user is in this region, send the traffic to this server. And if the user is in this region, send the traffic to this server. So as a user, when we hit this URL, all of our traffic will go to server 2 because we are closest to the Mumbai region, right? So you can see this will go to the weighted routing, which is running on server 2. So even if you try hitting that, your traffic, you will also see the same response. Go ahead and try that and let me know.
Yes, sir. It's showing as weighted routing policy.
Okay.
Yeah, same weighted.
Yeah. So yeah, I mean, that's basically what it is. All right. Any questions?
No, sir.
Okay. The next type we have is your failover routing policy. Now, failover routing policy is mainly used for your disaster recovery. All right. So if you want to have a primary and a secondary setup, so that if something goes wrong in the primary, you can quickly switch to the secondary. Then you can make use of your failover routing policy. In this case, you can automate it. So if something goes wrong in your primary, it will automatically fail over to your secondary environment. That's your failover routing policy. So failover routing lets you route traffic to a resource when the resource is healthy. So under this, you will be having a health check. Okay, so for the primary resource, you'll be having a health check. Now, as long as the primary resource is healthy, the traffic will be routed to the primary resources. If the health check fails, it will automatically fail over to your secondary servers. Okay, so the primary and secondary records can route traffic to anything from an Amazon S3 bucket that is configured as a website to a complex tree of records. So let me show you an example for this. Let me again delete this records. And now before we begin with this, we'll need to first create a health check. So we'll go to health checks and we'll create a health check and then give a name. So let's say fail over demo. And then what do you want to monitor? Do you want to monitor an endpoint? Endpoint is nothing but the URL or the status of other health checks or the status of a CloudWatch alarm. In my case, it's going to be an endpoint. Now, is that endpoint an IP address or a domain name? So we'll go with the IP address. So is it over HTTP or HTTPS or TCP? So in my case, HTTP. What's the IP address? So let's say the server 1 is going to be my primary. So we'll take this and we'll give that over here, and then the port number and then the path. So this is same as what we had done in your load balancing, the same type of health checking that we are doing here. Now, so this will be the URL, so it will validate this URL. So basically it will expect a response. So when my route 53 will hit this and it should get this response. As long as it gets this response, it will mark it as healthy. If it does not get a response, it will mark it as unhealthy. All right. So now you can also do some advanced configuration. Like let's say I want this every 10 seconds. When do you want this to be marked as failure? So 3 times if I don't get anything, and all these things you can define. Then next, you can also set up an alarm. That is, you can send out a notification. So if this health check fails, right? So in production, this is important, right? So you want to get notified if something goes wrong in your primary environment. So you can use your topics, right? So in our case, we're not using that, and then click on create health check. So this will create a health check for us. And like I said, this will help us to monitor the overall health of our primary and secondary. So in this case, I know this is still unknown. So we'll wait for this. In the meantime, we will go and create our hosted zone. So we are going to create a failover routing policy now. So we'll again go to create record, and this is going to be a failover, and the primary server is going to be this one, and this is going to be a failover routing policy. And is this a primary or secondary? So in my case, it's a primary, and here we can give the health check, whatever we have defined, and you can give a name to this. So let's call this as primary server, and we'll create one more record for the secondary servers, the secondary environment. So in my case, this will be server 2, the secondary environment. We will add that 60 seconds failover, and then in this case it's going to be a secondary. And for the second, if you want to have a health check, you can have it, but we have created the health check only for the primary server, so we are not going to use that. And this will be your secondary server, and then create records. Now, as long as the health check that we have defined, all right, as long as this health check is healthy, the traffic will go to your primary servers. All right. So even if you hit this, as long as the server is healthy, so the health checks that we have defined over here, as long as this is healthy, the traffic will go to the primary server. So all of us will see this simple routing policy. All right. Go ahead and try this and let me know if this is what you can see.
One, sure. Yeah, I got the same.
Yeah. So all of us will see the same thing, right? Because we have defined our primary server as the server one. Now, what if something goes wrong, right? So let's say the primary server has some issue. Okay, so let's say here, so quickly log into that. Let's say I will stop the service. So service HTTP stop. So essentially now, when I hit the IP, this will not work, right? So now what will happen is the health check will fail. So let's wait for the health check to become unhealthy. So once it becomes unhealthy, it will automatically fail over to the secondary servers. So let's wait for this. So I'm still waiting for this. Okay. So now this is unhealthy, right? Now, if you refresh that URL once again, you will see that it will automatically fail over to your second server, which is your weighted routing policy. This is your failover routing policies where you can handle your disaster recovery and where you can have a primary secondary setup. Questions?
No, Rafi.
Okay. The next routing policy that we are going to look at is your geolocation. Now, geolocation is based on the location of the user. For example, let's say if I have users in India location, they should be routed to one web application or one server. And if my user is in, let's say, US, they should be routed to another application. For that purpose, we can make use of your geolocation routing policies. All right. So geolocation routing lets you choose the resources that serves your traffic based on their geographic location of your user. So Route 53 will basically evaluate whether the user is in this location or not. So, sometimes you might see that, when you try accessing some application, you won't be able to access that application based on the region. However, if you connect to a VPN, which is in a different location, and then you try to access that application, it will work, right? That's basically an example of your geolocation routing policies. So for example, you might want all queries from Europe to be routed to a load balancer in the Frankfurt region. And likewise, if you have your users in India, you want this to be routed to your Mumbai region. When you use geolocation routing, you can localize your content and present some or all of your website in the language of your users. So basically, based on the location of the users, if you want to route the traffic, we can make use of your geolocation routing policies. So let's go back to the hosted zones. I'll go over here and let me delete this and we'll create new records. So this time we are going to create location based. So let's say server one, and this is going to be your geolocation and your location, right? So let's say India, for example. Right? So Any traffic coming from the India location should go to this server. So let's say India users, and we'll have one more record. And again, the name will remain the same. The URL will remain the same. But what will happen is your Route 53 will evaluate from which location this traffic is coming in. Okay, so Route 53 will take care of that. So again, geolocation, and now let's say this will be your Europe, for example, right? So let's say Europe users, and then create record. So this becomes your geolocation routing policy. So if my traffic is originating from Europe, it should go to this server, and if my traffic is originating from India, it should go to this server. That's where we can make use of your geolocation routing policies. So again, in our case, all of our traffic will go to this server, right? Which is your, okay, sorry, I have to start this. So all of our traffic will go to this server because we are from India location. This is your geolocation routing policies. Questions?
No, Ravi, it's clear.
No, sir.
So we looked at simple weighted geolocation, latency, failover. So we have this, okay, so earlier we used to have this geo proximity, but now they removed it. So I'm not going to talk about that. All right, so I'll go to your multi-value answer. Now, the multi-value answer routing lets you configure Amazon Route 53 to return multiple values such as IP addresses for your web servers in response to DNS queries. So under this, basically what you can do is, again, you can have multiple web servers. You can map multiple web servers to this. So you can specify multiple values for almost any record, but multi-value answer routing also lets you check the health of your each resource. So Route 53 returns only values for healthy resources. Now, this is not a substitute for a load balancer, but the ability to return multiple health checkable IP addresses in a way to use DNS to improve the availability and load balancing. So under this, again, what you will be doing is you will be mapping, so your multi-value answer, you can map multiple IP addresses. All right, so something like, let's say I want server 1, and then let's try this one as well, and let's say this will be multi-value. All right, and set this to 60 seconds, and you have the option of giving a health check, and let's call this as multi-value demo, and then create the records. Okay, A does not support, I guess. Okay. Okay, it does not support, I guess. Yes, well, yes, it will not. You have to have one by one. So again, this will be server. This will be multi-value. So again, here we have a multi-value answer, multi-value records. We have which we are pointing to multiple IP addresses, right? So when we hit this, what happens is your multi-value answer will evaluate the server and will automatically send the traffic to those servers. You don't have to worry about it. Questions?
No, sir.
No.
I'm not sure what is this IP based. I'm looking at it for the first time, but um, I would say you don't have to worry about it because simple routing weighted or failover latency is what is very commonly used when we talk about your routing policies in your hosted zones. All right. Now there's one more thing I want to show, which is your alias records. Now at any point, okay, sorry, there's one more thing I wanted to talk about is your CNAME records. Now you can also create your CNAME records. So until now we have been creating your A records. Right now we know that your A record is for an IP address. Now what if you have a URL? Now that's where we can make use of your CNAME records. So let's say, for example, if you look at this server, there's a URL available over here, right? So this one, anything that is ending with your .com, it's a URL. We can map this. So if you can either make use of the IP address. In that case, you will use a record, or you can use a URL. In that case, you will use a CNAME record. So for the CNAME, I can give that URL, right? And I can create this record. Okay, so I have to, right? So this becomes my CNAME record. And if I hit this, now this is also doing the same thing, but now it's just that we are using a URL to URL mapping instead of IP address to URL mapping. So whenever you have an IP address to URL mapping, you can go with the A record. And if you have a URL to URL mapping, you can go with the CNAME records. Make sense? Okay. Now, the last thing I want to talk about is your alias record. So here, if you see, we also have something known as alias records. Now, alias records can be used if you want to map to, load balancer, like application load balancer or network load balancer, or your S3 websites, static websites that you have created. In that case, you can make use of your alias records as well. So generally, if you have something running behind a load balancer, you can simply map that to your alias record. So let's say, for example, we will quickly create one. 1 minute. So let's say we will quickly create one load balancer over here. Okay, so we'll go to load balancers and we'll create a new load balancer over here. We'll go with the application load balancer and demo. We are running this in the default. We'll select all the subnets because I'm not sure where my instance is running. My security group, and this is going to be on port 80. We'll create a target group for this. We are going with instances. That's my VPC health check. So we are looking for index.html file, and we'll set this to 2. We'll do this every 10 seconds. Next, we are going to map both the servers to this, and then we'll create this record target group. So this will create the target group. We are going to map that over here, and we will create this load balancer. Now this load balancer will have a URL associated with it, right? So here is a URL. Now I can map this to my Route 53 by making use of these alias records. So let me show this once again. So we'll again create a record and let's call this as alias. And we can choose your application load balancer, in which region you're running it. So in my case, I'm running it in the North Virginia, and you should be able to see the load balancer here automatically. And then click on create records. And now what we can do is, instead of hitting the load balancer URL, I can simply hit this URL. So what this will do is, this will route the traffic to the load balancer. The load balancer in turn will send the traffic to the target groups that we have defined, the servers that we have defined. Make sense?
Yes, sir.
Yeah.
Okay. So just waiting for this to become healthy. And once this becomes healthy, if I hit the Route 53 URL, you will see that. So, I mean, this is same as hitting the load balancer, but again, generally at an organization level, we don't use, as a customer, we don't hit the load balancer. See, always think from a customer's perspective. If you are working with a customer facing application, the customer needs to have a URL, right? Easy to remember URL. So this mapping your load balancer to Route 53 is something very commonly that we do. So now if I hit this, you see, so it will basically, keep on switching. So now this is hitting the load balancer, and my load balancer is taking care of dividing the traffic between my server 1 and server 2, right? So this is your alias records. Questions?
No, sir.
So pretty much that's all I have as part of your Route 53 that completes your Route 53. Now, one important point I forgot to mention was you will be charged for creating these hosted zones. All right. If you create these hosted zones and delete it within 12 hours, you don't have to pay any money. But if you go above that, you'll have to pay 50 rupees per month. All right, so you'll have to pay money for these hosted zones as well. So if you're experimenting with this, create it and delete it immediately or within 12 hours. If not, you will get charged for this as well. All right, so yeah, so that completes your Route 53. That's all for today. Tomorrow we will be starting off with few more additional services that I wanted to cover, like your Cost Explorer, your budgets, encryption keys, how you can manage that. So we will talk about that tomorrow, right? That's all for today. If there are any more questions, let me know. If not, then thank you so much, and I'll see you guys tomorrow.
Thank you, Ravi.
Thank you, sir.
Thank you.